There we go. All right, so your exam's on Wednesday. What I'm going to do is I'm going to have it open at 11:40. I'll say a little bit more about that in a second. If you have a topic or a question you'd like to review, let me know in chat. And after we talk about some generic exam information, I will get to as many of those as possible. If there are no questions, I'll pull a couple things from what my last class asked. There's a couple things I want to go over also. But if you have questions, let me know and we'll go over them in a minute. So I'm going to have it open at 11:40 in the morning. You don't have to start it until 12 if you don't want to start it until actual class time. It's just, so essentially what's going to happen is I'm going to look to write a 40-minute exam. I've said this a little bit already a couple days ago. So I have this process that gives me a general idea of how long the vast majority of, well, shall I say, the people who are grasping the material in the amount that they should be. You know, if you're understanding the material, you should be able to do the exam in about 40 minutes. Some might take less, some might take more. So about a 40, maybe a max of 45-minute exam is what I'm shooting for. I have this process to, I give you essentially 5 times the amount that it takes me to do the exam. So if I'm shooting for a 40, 45-minute exam, I have to take the exam in less than 10 minutes. Because that usually comes out to be a pretty decent approximation. The large majority of people can usually finish by the end. Of course, this is a 50-minute class, so there's that kind of little bit of buffer there already, but I'm going to set the time limit to be 60 minutes. This is going to be an official time limit. So that's also why I'm opening it up a bit earlier, 20 minutes early, in case, you know, you need to go to a class directly after this and you want to have that extra 10 minutes in case you need it. Then you can start it an extra 10 or 20 minutes early and make sure you can finish before you have to be somewhere. Again, you shouldn't necessarily have to take 60 minutes. It shouldn't be a 60-minute exam if you're understanding the material well enough. But this is an official time limit. Your quiz time limits have been unofficial. So what that means is after those 60 minutes, it's going to submit itself. Okay? You're not going to have the option to keep going. It's just going to be done. You know, imagine it's an in-person class and we just got to leave because the next class has to come in. That type of deal. You have 60 minutes and only 60 minutes. If you receive extra time through the disabilities office, it should automatically show up as, I believe most is 1.5 times, so it'll be 90 minutes. If you open your exam and you expect that you should have extra time because you are signed up with the disabilities office and it does not say 90 minutes, close it immediately and email me or pop into the Teams. I'll talk about that in a second. I have all of your names. I should be putting them through, but if for some reason something happens and it does not read extra time and you should have extra time, you need to let me know. If you haven't gone through the disabilities office, don't expect extra time, okay? It needs to be officially through the disabilities office for me to give you extra time. So that's a thing. So I haven't completely finished the exam yet. I've kind of started it, but to give you a general idea of about how my 50-minute class exams usually run, they're usually around 15 questions. 1 or 2 questions might have, part A, part B, part C, so it comes out to be more than 15 parts, but about 15 questions. There's usually about 8 multiple choice. I'm pulling these from, I looked at last semester's exam and there were 8 multiple choice. There were 2 find the error. I'll talk about that in a second. And there were on that exam 4 free response. So on the last semester's exam, it was 14 questions. Some of them had 2 or 3 parts to them, possibly in the free response. Find the error questions. If you haven't looked at the review yet, there are some examples of those on there. Essentially what it's going to be is I give a question and find a linear equation between 2 points. There's some worked out work and you need to point out where there's any errors. Now I'm going to scroll up in just a second to the review and look at one of the questions on there. So if you don't want to, if you haven't been able to look at the review yet, you don't want to, spoiler alert, you might want to look away. But also, I think it's really important for me to say exactly what I'm expecting with these types of questions. So this is one of them on the review. So it was find a formula for the linear equation between 2 points. So note that there were 2 errors here. There was the first one in the slope. They calculated it wrong. And then they also plugged the points into the wrong spot when they used the y equals mx plus b format. With these types of questions, you find the error and you tell me why it's an error. You don't have to correct it. If you only correct it, I don't promise full points. I promise most points, but I don't promise all of them because I actually want to know that you see what's wrong with it. Like, so notice in the slope one, I didn't just say the actual slope should be blah, blah, blah. I said they set this up wrong. They set it up as a y2 minus x1 over x2 minus x1. There should be a minus in there. That's missing. Instead of the actual correct slope formula. If you give me something like that, they didn't follow the correct slope formula even would be acceptable. I'm very lenient on what I accept in terms of your reasoning, but I do want you to actually give me a reason, not just here's the right answer. If you do want to correct it, you can. If you can't think of any reason and you're like, I don't know how to explain this, but the correct answer should be blah blah blah, you'll pretty much be good. But I might take off maybe half a point if I'm feeling cranky because I really do want why is it wrong. The other thing that's really important with these is once you find an error, you assume that that value or whatever it is then correct for the rest of the problem. What I mean by that is they found a slope of 2. That's the wrong slope, but now that you've pointed out that it's the wrong slope, you're going to assume for looking at the rest of the question that that slope would have been correct and see if they did everything else correctly. So like the fact that they plugged in 2 for the slope in the y equals mx plus b is not a problem. The problem is that in the y equals mx plus b, they put the x in the y spot and the y in the x spot. So that's a completely separate error from the slope. If that line had read what it should have read and they finished it completely correctly with just the wrong slope, then you would just have the one error of the slope. Okay? So it's essentially once you find that error, you kind of then take that to be, okay, well, what if I assume that that was right? Did they do the rest of the problem correctly? That's essentially how I grade. That's kind of how I grade your questions. If this were something that I were grading, I would take points off for the wrong slope and I would take points off for you plugging it incorrectly, sorry. But say you had found the wrong slope but then done everything else correct, you would have just lost points for the slope. So you kind of take that error and then assume it's correct and see if they did the rest of the process correctly. Hopefully that makes sense. Let me know if it doesn't. Which is why I say down here, I was trying to make a note, since the rest of it is correct process, those are the only error. So, sorry, there's only one error. No, that's not true. I'll have to fix that. I think that's because I actually didn't see the wrong slope at first. So that's the thing. But so since the rest of it's correct just with the wrong numbers, they did the process correctly. They multiplied the 2 and the 8 to get 16. They subtracted 16 from both sides to get -6, and then they used the slope and the b value that they found to form a quote-unquote correct answer. So everything else was quote-unquote correct just with their wrong numbers, so it's considered correct. You've pointed out the errors. Anyway, so there will be maybe 2 of those. I do a lot of those on these online exams. No, you're fine. I actually didn't say that yet, so that's a good thing to clarify. It's on Blackboard. Just like your quizzes, it's going to be in the same spot. The assignment tab on Blackboard is where you will find the exam. Again, it will open at 11:40 as long as you take it, around the normal class time, you're fine. I will clarify. Yes, it will be open at 11:40, but it's going to close at the end of class. Okay, so you don't have whenever the heck you want to take it. And it's expected that you're taking it during the class time. Okay, I need to tell that to my other class in case someone thinks it's not that. You have to take it during that class time. The reason I'm opening it 20 minutes early is so that anyone who needs to leave after class can have that extra time because the time limit is 10 minutes more than the class time. That doesn't mean that so our class ends at 12:50. If you end your exam at 1 p.m. or 1:05, you're fine. You know, it's just that you can't come in at 12:45 and start the exam. It's not going to be there anymore. So that's the thing. You're fine, Sri. So, what's next? Peyton, do you have an exam review? Possibly. She might be typing in chat, so let me babble while she might be answering me in that. Okay, so Peyton has her normal session tonight. So feel free to go to that if you want. I always tell you guys, or I'll try to always tell you guys, Zoe's as well when it comes to exams. Zoe has a test review tonight as well at 7 p.m. So remember, you can go to any SIs that you want. So if Zoe's schedule works out better than Peyton's, that's fine. If you want to go to a completely different SI, that's fine. It's just I suggest either Zoe or Peyton because they cover my classes and the other classes might be a little farther than we are, might be covering different material, might not have a test on Wednesday. So Peyton has hers normal time tonight at 6 p.m. How do you go to Zoe's? I believe you just need to get the link, which I can actually get you right now. So to find absolutely anyone's SI schedule, usually when I need to find SI, I just Google University of South Carolina SI sessions. And then it brings you to a page and you can click on Math 122. Zoe's. Today is Monday, so it would be this link. So Zoe's Monday link is apparently this. Hopefully it's not different for the test review, but I put that in chat. So that's Zoe's, if that works out better for you. That'll be a thing. What else? Other generic stuff that I need to talk about. I'll be on Teams from like maybe 11:52 to let's say 1 p.m. I say 11:52 because I told my last class that I would be on until 11:50 and then give me a hot second to pop over. So I know that the exam will then have been open for 10 minutes already, but because I have such back-to-back classes, I gave them up until 11:50 and I'll be in Teams and then I will, as quick as I can, jump over here. So if you're trying to start it a little early, you'll have to wait a little bit to ask me questions, but just keep going and have your questions off to the side. And so I'll be on Teams from 11:52-ish, you know, as soon as I can after 11:50 up until about 1 p.m. I might stay on a little later just in case. You don't have to be. I don't really find the purpose of us just all sitting here. I'll be twiddling my thumbs unless people have questions. If you want to be here and you just want to sit in the Teams meeting while you take the exam so that it's just easy to pop over and ask questions, you can do that as well. Whatever floats your boat. But I will be here on Blackboard, on Teams, twiddling my thumbs. Last thing I want to talk about before we get to some of these questions is I want to talk about what's okay and then not okay to use on the exam. So this is a online exam. It's going to be open notes because I'm not about to try to fight people who are going to try to use them anyway. So it's open notes, so that's perfectly fine. You can use your notes. Now, do not think, oh, it's open notes, so I won't study that much. Please, for the love of all that is good and holy, study as if it's a closed note exam in person and you can't look at anything. study as if you won't have anything to help you out. Because if you're looking at your notes and you have to go back to your notes for every single question to figure out how to do it, you're going to run out of time. You are going to run out of time. So you do need to know the material well enough that for the vast majority of them, you hopefully don't have to try to use your notes. You can just do them because you know how to do them. Okay, focus a lot on processes. That's the best option. That's the best advice I can always give when studying for math is don't just do practice problems. Do practice problems. But if it's something like find the equation of a linear line, you might want to remember, okay, it's a linear equation. I need to find the slope. I need to pick a point and plug it into y equals mx plus b. I need to solve for b. I need to write my answer. If you have those 4 steps in your brain, you're good to go. No matter what question I throw at you, if it says find the linear equation, you can talk yourself through those 4 steps. So try to really focus on processes if it really has one. Some topics don't have really clear-cut processes like that you can just note the steps like that. But that's the thing. So it's open notes, but don't rely on your notes too heavily. You can, of course, ask me questions. So I'm going to be very specific and say Erin Hannah. I can't even spell my own name. Questions. So again, I'll be on Teams. If you email me instead, Teams would be better. I will try to be checking my email, but I can definitely see myself being too focused on Teams and then forgetting about my email. So Teams would be better, but you can ask me questions, of course. You can use anything that's already available online. So any resources that are already available online, I'll say a little bit more about that in a second. And of course, you can use a calculator. If you don't have one, I highly suggest Desmos. It can graph, it can do scientific stuff, it can do whatever you need. Now, already available online means that it's already there before the exam starts. So what that does not mean is that you cannot post to Chegg, Reddit, Stack Exchange, whatever, to receive answers. You cannot ask people to do the test for you, and that includes internet strangers. Likewise, you can't talk to others. You can't get answers from other people. Trust me, it's easier to tell than you think. Oh, it lagged, so that didn't come up. 1 second. My laptop's angry, so I'll just talk. I caught a couple people on the final exam last semester that very obviously worked together. It's not that hard to pick up. Also, especially if you're a fan of Chegg, if you're going to try to post my exam questions on Chegg, first of all, they're not already there, I check. So if the exam questions aren't on Chegg before the exam and then magically they're on Chegg after the exam, someone's not going to be happy. And a lot of the times the answers that you will get in that short enough time limit to be able to use it on the exam are wrong. That's the easiest way I've found that people put my stuff on Chegg is because their answers are wrong. And when I just match them to the wrong Chegg answer, then you're done. Anyway, so just don't do it. You can use open notes. You can use absolutely anything else you can find online. If you can Google a similar question and you find a similar question, then use the similar question to help you figure it out. That's fine. Just don't get answers from other people. Anyway, I'm not salty about it. No, not at all. Any generic questions about the exam before I go over? I think there's 1 or 2 things people posted. Maybe just 1. There's just 1, but then I want to talk about something anyway, so. Alrighty. So, supply and demand. Do you mean one where we find the demand equation or one where we find the equilibrium point or a little bit of both? Both. Okay. So let's do a bakery, because that's always my default. Finds that they sell, let's do 200 cupcakes if they are priced at $5. Oops. And they sell 275 if they are priced, whoa, at $3. Assuming demand is linear, because that's the only type of thing we're dealing with right now. Well, we have exponential equations now, but we haven't dealt with supply and demand in terms of exponential. Find demand as a function of price. I'm switching it up a little bit. So I'm going to wait a couple seconds so y'all can write that down. Actually, I'm going to look up something really quick while y'all are doing that. Oh, I didn't put it on there, so I can't put that on the test. Oh well. Okay. So, function of price. So demand is a function of price. I'm going to be very in depth here. So demand is a function of price. The function of price wording, remember, should tell you f of p, function of price, f of p. Now, some of you may want to write equals d for demand, and while I would accept that, I'm going to say the better thing to do is so demand and supply are in terms of price and quantity. Oops. So supply and demand always relate price to quantity in some order. So instead of writing equals D for demand, I'm going to write equals Q for quantity. Equals D for demand wouldn't be wrong per se, but to then go on to do later, like if this was just the question, I'm going to add on pieces of this question afterwards, but if this was just the question by itself and had no other parts, that would probably be fine. But if I were to add on some extra parts, like asking you to find revenue or asking you to find an equilibrium point, you might get confused if you don't recognize that that's quantity. So I'm going to go ahead and write equals Q for quantity. So what that would mean is that the points that we have, the points that we need to use to find this equation, since, you know, we usually write x, y, the thing inside of the function name is always going to act as the x value. And the thing that we're solved for is always going to act as our y value, if you like to think of things in terms of x and y. If you don't need to think about things in terms of x and y, then you're good to go. So we'll have our price and then our quantity. So our 2 points will be 5, 200, and then 3, 275. Because we're using a P, comma, Q here. I'm going to cross that out, not because it's wrong, but just because it's the wrong variables. So, equation, we need a slope. In general, that would be a change in y over a change in x. So in this case, it's our change in Q over change in P. So I would do 275 minus 200, 3 minus 5. We'll get 75 over negative 2, which comes out to negative 37.5. So not too bad of a slope. And then remember, after you find your slope, you're going to plug into your y equals mx plus b, which in this case would be a q equals mp plus b. Pick whichever point makes you happier. I'm going to pick the 5,200 because I like it better. You should get the exact same b value if you use the other one. Negative 37.5 times 5 gets us negative 187.5. Add the 187.5 to both sides. Get that your b value is 387.5. So your demand equation would be negative 37.5 P plus 387.5. Questions on how I found that demand equation. So I'm going to do a little bit more with it in a second, but questions on how I found that. Now, yep, I was actually just going to get into that. So notice that here it was a function of price. More often than not, it's a function of quantity, but I do want to really hit home that that's not always the case. If this was a function of quantity, so then we'd have P equals F of Q. So essentially the points would flip-flop around. Which would make our slope a lot grosser, actually. Because you get negative 2 over 75, which comes out to be, and I only know this because I did this exact question in my other class. I don't just magically know what that is. So your slope would be negative 0.026 repeating. And then you'd have to find your b value separately. So since he specifically asked, let me just finish this. So say I still want to use the one with the 200 and the 5. It would now become 5 equals this negative 0.0, let's just say 26, and just cut it off, times 200 plus b. Oh god, that's gross. Negative 0.0, negative 0.026 times 200. Negative 5.2. So that didn't come out too bad. Nope, not negative, not negative. Positive 10.2, because you would add the 5.2 to the other side. So your equation would be P equals negative 0.026 Q plus 10.2. So if it was a function of quantity, we'd have a completely different equation with P solved for instead of Q. So be careful, read your question to make sure you're setting it up in the correct fashion. Now, what are some other things we could do with this? I want to do two things. One of them was asked about, one of them was not, but I want to do it anyway since it'll be quick. So the other thing that was asked about was supply. So say if supply, now we're going to use this one that we just found for this next part. So just use the quantity equals one. I'll talk about that in a second, Katarina. So if supply is given by, I'll have to have Q, well, I don't need to, but it would be nice of me to do Q equals here as well. So supply would be something like, I don't know, 20Q plus 50, sure. Find the equilibrium point. So equilibrium point is where supply equals demand. Whoa, sorry. That should be a 20p plus 15. not Q. Shouldn't be a Q in both spots. Is where supply equals demand. So since both of these are solved for Q, we can just set them equal to each other. If for some reason I decided to be really nasty, which I probably won't be, on the exam and have one of them solved for the other one, you'd have to rearrange it to have it equal the same value. But since they're both Q equals, we will just take these two equations and set them equal to each other. This will allow us, in this case, we're going to find the equilibrium price first. Which one you find first depends on how the equation is set up. If these were both P equals equations, we would be solving for quantity first. So just keep track, P is price, Q is quantity. Then yeah. So I would add the 37.5 over to the other side, get 57.5 P, and then subtract the 15. 387.5 minus 15 is 372.5. Divide both sides by the 57.5. 57.5. Price is going to be 6.478. Let's take 3 decimal places. I know it's a price, but for just the sake of solving the rest of the problem, let's go ahead and take an extra decimal point for now. I might make the final answer say 6.48 because it's a price. But for while we're finishing this question, let's go ahead and leave it as 3 or 4 if you wanted to decimal places. So that's our equilibrium price. So whenever you find the first one, it doesn't matter if you find price or quantity first. What you're going to do is you're going to take the one you find and plug it into supply or demand, whichever one makes you happier, to find the one you don't have yet. I would personally pick supply because it's a nicer looking equation. So I personally, oh my gosh, would plug it into supply. 20 times 6. Nope, 20 times 6.478. 129.56 plus 15. 144.56. Now, if you were to leave those as your answers on the exam, 100 perfectly correct. Fine. Would triple check my instructions in case I specified a round, but usually I don't ever specify rounding, so I just accept correct answers. But just for the sake of going a little tiny step further, I might say something like the equilibrium point is about 145 cupcakes. It was cupcakes, right? I can't scroll up. Yeah, it was cupcakes. About 145 cupcakes at $6.48. If you round up to the nearest cupcake and the nearest cent, I'd also accept that. We do want to be kind of careful just generically, so understand that that's not the exact equilibrium point, so things might get a little wonky, but it's close enough that we're fine. The only other thing I want to do on here, and then I'll answer your question, Katarina. Well, questions on how I found that equilibrium point. Cool. And if you're still typing, still type. But the only other thing I want to talk about is if I were to ask you for revenue. So let me remind myself of the demand equation because I've scrolled past it at this point. Oh, it's right there. The negative 37.5 plus 387.5. Usually you will be asked this question when you have the demand equation. Technically, you could answer the question with supply as well, but since it's usually stated in terms of the demand, I'll do it with the demand. Say I then asked you to find the revenue function. So remember, in general, revenue is price times quantity. So the thing about the demand equation, or supply, but again, it's usually written in terms of demand, is that it's either P equals or Q equals, depending on how you set it up. And it doesn't matter which way it's set up, you can still find the demand revenue equation. In this case, since it was set up to be a Q equals, what we'll do is we'll replace this Q here. And we'll have P times negative 37.5, P plus 387.5, and then usually you distribute that for your final answer. So if the demand had instead been a P equals question, then you would replace the P instead of the Q. But remember, you can also find the revenue equation given demand using that process. Questions concerned about that? Are there natural logs on the test? Up to what we've covered. So also you can take a look at their review. The only types of questions I can ask you are things we've covered up to this point. So there are stuff about natural logs that we haven't covered yet. Why isn't Blackboard opening this? Thank you. But, so what did I put on the review? I'm pretty sure I just put the expand and condense ones on there. Ooh, we haven't done a condensing one. That's because I was supposed to do one before we did this. So let's do one of those real quick. But essentially anything that's on your review is fair game. So there are some expand and condense ones. So let's do a condense one real quick because we didn't grab one of those the other day. So remember, we've got all of these, log properties. We had the natural log of A times B, gave us the natural log of A plus the natural log of B, and so on and so forth. I'm not going to write them all out to save time. But then we could expand and condense things. And we got to the expansion, and I forgot that I was supposed to do some condensed questions before we started. So say I had something like this, minus, say, 1/2. Sure, that's a Z. So say I had something like this, and I asked you to condense it. So essentially we're starting with things that look like this and we're bringing them back together to the just one log. So one of our rules is dealing with the exponent. And remember, if we have an exponent inside of a log, we can bring it outside of the log. So essentially, if we're starting with a number outside of a log, it can be forced back into the logarithm as a power. So let's do that for, both of those that have the constants. Let me make that look like a 2. So I take those constants and put them back into the logarithm as powers, which is the reverse of what we did on Friday. And now when you deal with these other rules, these other 2 rules that we really deal with here, let me write this one just to be able to refer to it. You want to do it from left to right, and you should really focus on doing it one at a time. So the first thing we're going to condense is these first 2. So since that's subtraction, it's going to condense into one logarithm with division, where we have the x to the 5th in the numerator and the z to the 1/2 in the denominator. Now, if you get really good at these, you can do it all at once, but, taking them one at a time will ensure that you don't get it wrong. Because sometimes you could accidentally mess up the order and you might think, oh, well, this thing came behind a negative, so it must be in the denominator, which is actually not going to be the case, which is why you need to be very careful with parentheses when you're expanding. So in this case, when we want to condense this, we're starting with addition. So our rule that deals with addition is it's going to bring it into one log with multiplication. So we're able to condense this. Now there's 2 ways you could write this. You could just, multiply on the side. I personally would put it in the numerator, but technically the other one is also correct. Because remember, if you're wondering why the heck it went in the numerator, remember this is technically x plus y over 1. So when you multiply those 2 fractions together, you multiply the numerator and the denominator, so the x plus y only goes to the numerator. So that is essentially the backwards process of what we did on Friday, which is why I felt comfortable still putting it on the exam. It's not a a wild out there thing that you hadn't seen yet. There are a couple questions of that on your review, so that is fair game on your exam. There's also some homework questions. So remember, your homework's being pushed back to be due on Monday, but if you want to try it next Monday. So if you want to try to get some more practice, there are some questions of expanding and condensing on your homework as well. Questions, concerns about how that went? Okay. We've got 10 minutes. I want to try to do one last thing. I think I answered all the questions that were there. There's only really the one and then the logarithm one. So if anyone has a question, throw it out there in the next couple seconds. Otherwise, I want to talk about exponentials when you have a table, because I want to make sure one of the steps is understood. Okay, I'm not seeing anything, so we're going to finish with, that doesn't need to be that long, this question. Actually, let's do this. So running a little low on time, so I'm not going to do the full linear piece, but remember, if we were trying to check if these were linears, we would check linear. If this was linear, we would check our change in y over change in x. These are not going to match by any means, even if you take the ratios. So let me just write down this last one real quick. So if you take those ratios, they're not going to equal each other. If we had a bit more time, I would have done that out a bit more fully, but we're running low and I want to talk about the other part of it. So those aren't the same, so it's clearly not linear, okay? Say we wanted to figure out if it was exponential though. And I'll hold on a couple seconds so y'all can catch up. Say we're low on time, we're not that low that I need to rush that much. So say you wanted to figure out if this was exponential. So remember, exponential, we're looking for a constant factor. Linear's constant slope, exponential's constant factor. So we're going to want to take ratios. And remember, the y value of the larger x value must be the numerator. That might mean that you're putting the smaller y value on top, which is okay. In this case, it's going to be the larger y, but sometimes it'll be the smaller y on first, as on top on the numerator, as long as it's the y value associated with the larger x value. Now remember, there's also a bit more of a trick than just taking ratios here. So between those first 2 points, between 1 and 2, we can just take their ratio because the x values between 1 and 2 just increased by 1. So we would take that ratio, we would find it to be 1.234. Then if we wanted to go to the next one, we would set up the ratio. But notice that the x values there increased by 2 instead of 1. So we would have to take a square root of that ratio to find the possible factor that we're going to compare. And square root that. You will get approximately 1.233999703. Well, no, you'll get exactly that actually, which is approximately 1.234. If you then continued on to the next set, you would set up the ratio. But since the x values increased by 3, you need to take the cube root. Now, doing a cube root or a higher root on a calculator is, I mean, you can do it and it's not that hard, but I find it easier just because I don't have to go into the math button to make it a fractional exponent. So that's equivalent. But if we do this, we will find that this comes out to be, actually I don't have this one yet, so 1 second. 1.23400066, which is approximately 1.234. So when we were first going over this, I said make sure that they match up to at least 3 or 4 decimal places. So yes, technically 1.234 is not the same as 1.233999703 isn't the same as 1.2340066. But up to 4 decimal places, they are all 1.234. And the reason that there's a little bit of error here is because I rounded those numbers in the table. Like I cut them off. They have larger decimal points, larger decimals than I wrote down. That's why it's weird like that, which is why we will accept up to 3 or 4 decimal places actually being exponential. So this would be exponential. Now, the main thing I wanted to talk about in this question, first of all, are the questions about how I got any of that. Okay. The main thing I wanted to do with this question is, great, I've found the factor, I know that it's exponential. What if I actually want the equation? So we want some p naught a to the x in this case, since I wrote it as an xy. We know what a is. So remember when we defined a, it's called the base, but it's the factor. And I always said if you see the word factor in the question, that it gives you your a value. So since we're finding common factors, in those ratios, that means that the a value is that 1.234. We don't have p naught here because we don't have the value when x is 0. If we did, we could just use it. So we have to find p naught. How we find p naught is that we're going to pick whichever point makes us happier from the table. I'm going to pick 1, 5. And we're going to plug it into the general form of the equation with the a value. So we're going to have 5 equals, don't know what p naught is, that's what we're trying to solve for, 1.234 to the first. Since 1.234 to the first is just 1.234, we can just divide both sides by the 1.234. Divide both sides by the 1.234, you get approximately 4.052. What the heck? Let's take 3 decimal places. Leaving your final equation is 4.052, 1.234 to the x. So the main thing I wanted to touch on about this was that the factor that you're finding in those ratios is the a value of the equation. I don't think I was very clear about that before. So I want to be clear about that now. Questions, concerns about that? All right, we are out of time. Well, if you have any questions, feel free to stick around for a little bit. I can stick around for a little bit before I've got to go grab lunch. My biggest thing, study the review. If you haven't done the review yet, do it before Wednesday, okay? Make sure you can do these things with very minimal notes. Like if you're doing the review and you have to look at your notes every once in a while, that's fine, but then make sure that after you've used it, you then feel confident that you could not use them as much. Because if you're relying too heavily on your notes and on looking stuff up, you will run out of time. So look over the review. There's also a list of topics in the blank review. Look over those. because there are sometimes some questions that don't make it on the review that are in there. I believe everything that's on the difference between but anything on those topics is fair game. I believe the large majority of them, if not all of them, got into the review questions. But just look over those topics as well and make sure you know what all of them mean. Make sure you'd be able to do a question that involves that, and you should be fine. So if you need to leave, feel free to leave. If you have questions, feel free to stick around. Otherwise, I might not see you on Wednesday, but exams on Wednesday. Study well. Let me know if you have questions. May the odds be ever in your favor. And yeah, see you Wednesday.